All right, so one of the things that we begin to forget as we develop derivative formulas is that we're interested in the equations of tangent lines at certain points. And so I wanted to work this out with you. Let's do one of these, find the equation of the tangent line at a certain point. So here's my function. I'm going to use all these new fancy tools that we have. This is like opening a box of cordless DeWalt tools. They're so much fun to use. Let's try them out. I'm going to use them to figure out the equation of the tangent line. And so here we go. I'm going to begin by computing g prime of x. And so for g prime of x, I get, what, 3? And then I need to think about how I write g. I'm going to write g as 3x plus x to the minus 1/2. That's actually what g looks like. This is g of x. So g prime is 3 minus 1/2 x to the minus 3/2. Some of us aren't liking those negative fractional exponents, but don't worry about it, at least not yet. So I'm going to rewrite g prime as 3 minus 1 over 2 x to the 3/2. And you need to realize how to interpret x to the 3/2. This is just 3, 1 over 2. And you can think about x to the 3/2. Here, let's do it over here. X to the 3/2 is the square root of x cubed. It's x to the 1/2 all cubed, or square root of x cubed. Square root of x times square root of x times square root of x, you just get root x times x. So you don't even have to write that out. You can just leave it like this. But for those of us that are nervous about how do you work with that, that's all that's going on. There's just a times here. Okay, oh, that's a minus. Don't forget the minus. It's 3 minus that. Let's clean this up a little bit. All right, so that's g prime. I'm interested in g prime at the point 1. So g prime of 1, it turns out, is just 3 minus, well, plug in 1. You could have plugged 1 right in there. I think we're comfortable with 1 to the anything is 1. So this is just 3 minus 1/2, which is 5/2. So in this particular problem, you did not need to simplify this, but I wanted to take the opportunity to point that out. At this point, you can write down the tangent line. Here we go. Y minus the y value of 4 equals m, our slope f prime, times x minus the x value of 1. And of course you can reduce this to y equals 5x over 2 plus 3/2. And so there is the tangent line. Now I've got a version of Mathematica on my iPad, and I went ahead and graphed that for you. Here's our function that we were graphing, and you can see the tangent line, and it lines up beautifully at 1. I don't have a pointer when I'm in this app, but you can see that it lines up really nicely at 1. All right, so let's go back to our notebook here, and I want to do one more example with you. So we're asked to find the points on this curve where the tangent line is horizontal. So think with me, tangent line being horizontal means it has slope 0. So I'm looking for where is the tangent line 0. Where's the derivative 0? I want to solve for y prime equals 0. Make sure that you can see that's what we're after here. So I'm going to go ahead and say, well, okay, fine. Y prime is 4x cubed minus 12x plus 0. So I can factor out what? Let's see, a negative 4x. I'm just going to do it actually as a 4x, and I get x squared minus 3. And I want to solve this thing equal to 0. So y prime equals 0 means that I want to solve 4x times x squared minus 3 equals 0. And that tells me three things: x equals 0, x equals plus or minus root 3. Those are the solutions to this problem. These are the x values where the tangent is 0. So let's go back to the Mathematica notebook. I didn't have this typed in ahead of time, but that's okay. We can do it together. So let's see. We're going to go ahead and say plot, and then I want to plot our function, which was what? X to the 4th minus 6x squared plus 4. And we're interested, we want to cover all the way down to minus root 3. So let's start and see if we can go from, like, let's say x goes from negative 2 to 2. Let's just try that and see what this looks like. Interesting. So here we came up with 3 solutions, and you can actually see them. Let's plot just a little bit more so we can see this graph a little clearly. If I can even move, yeah, there we go. Oop, nope. I want to go from my space adjustment doesn't work here, so you have to get it just right. So -3 to 3. All right, there we go. So now you can actually see where those horizontal tangents occur. They occur at the minimums. I can't point, sadly. They occur at the minimums and also the maximum. All right, so that's that. We were able to find those points not by looking at the graph, simply by using calculus. And we're going to see later on in chapter 4, that's a really big deal. And there's a lot going on here that we can talk about another time. I want to end this lecture with one last remark. And the remark, we'll just do an example. So if I give you this, you should recognize this function is a line. It's linear. Yes, it's also a polynomial, so it's super friendly, but the takeaway is it has degree at most 1. And so if you were to graph this thing, let's actually sketch a quick graph by hand. Whoop, my auto straighten is not working, so it's going to be a sloppy axis. Oh well. The y-intercept is 2, the slope is 3, so we're going to go up 3, and we can go ahead and try to put a line through there. Okay, very good. And so the question is, what's f prime? And so when I compute f prime of x, well, formula-wise, it's easy. I just get a 3. Hopefully you agree it's easy. If not, get some help. Make sure that everything clicks. So I'm just using the power rule. Derivative of 2 is 0. Pull the constant out, the derivative of x is 1, and so I'm left with 3 times 1, which is 3. Okay, what does that mean? Well, I need you to realize, again, the tangent line to a line is the line. If I were to zoom in at any point, let's say this point, if I were to zoom in at this point, then the idea is the function looks closer and closer and closer to a line, and that line is the tangent line. This line already looks like a line because it is a line. And so the tangent line to a line is the line. This line is its own tangent line. That's kind of cool. So I just wanted to make that very clear. We should actually write that though. Tangent line to a line is the line. Okay, very good. Another section done. Great job.